Hello, Chemistry 10HH students. This is Mrs. Altman, and we are on video number 32, Types of Chemical Reactions, Part 7. Here are our objectives for today's video. Pause here. We've talked about double replacement reactions, we've talked about dissociation reactions, and we have talked about acid-base reactions. What all three of those reactions have in common is that they are not what is called a redox reaction. So we're going to be switching to focus on reactions that are considered to be redox reactions, also known as oxidation reduction reactions. These are any reactions in which electrons are transferred from one substance, either an atom, molecule or ion, to another. Whatever loses the electrons is oxidized, and whatever gains the electrons is reduced. Something just to help you remember that: oil rig, oxidation involves loss, reduction involves gain. Pause here. In this video, our goal is just to learn how to assign oxidation numbers. Based off of what you're going to be learning in this video, these numbers actually do not really mean much on their own. It's going to seem sort of just like something that you have to memorize. And for the purposes of this video, it really is. But we will be looking at applications of it, and you need to be really good at it before we can look at these applications. These numbers will give us information in the future that we can use to make predictions about the chemical behavior of certain substances. Pause here. So here are the general rules for assigning oxidation numbers. We'll talk about the exceptions to these rules in class. So the oxidation state of any element on its own is 0. So whether I have O, whether I have O2, whether I've got O30, doesn't matter how many. If I just have one element and it's not paired with anything else, its oxidation state is 0. Second rule, oxidation state of a monoatomic ion is its charge. So for example, in NaCl, the oxidation state of Na is +1 and the oxidation state of Cl is -1. The third rule, the oxidation state of oxygen is typically -2. This is true unless it is on its own. We'll talk about one exception in class. You might be thinking, well, isn't oxygen always -2? This is also true when oxygen is not behaving as an anion. This is also true when it's a part of a covalently bonded substance. Fourth rule, oxidation state of hydrogen is typically +1. There's an exception we'll talk about later, of course, unless it's on its own as a part of H2. Pause here. Next, we have that the oxidation state of fluorine, even when it's a part of a covalently bonded compound, is typically -1. This is not true if it's F2. Next, if we have group 1 or group 2 elements in a compound, they're going to be +1 or +2, even if they're not your typical type 1, type 2 compounds. And then the last two rules, which are very important, the sum of oxidation numbers in a neutral atom is going to be 0. So hence Na and Cl, the +1 and -1 add up to 0. And then the oxidation state in a polyatomic ion is equal to its charge. I know this is a lot of information. The best way to learn this is just through a series of examples. We're going to do some in this video, and then we'll do a whole bunch more in class. Pause here. All right, let's work through these. So first thing I see when I look at this is type 1. So monoatomic ions will take their charge. Also, potassium is in group 1. So the oxidation state of potassium is +1. I'm going to skip over manganese for right now because there weren't any rules associated with it. The oxidation state of oxygen is -2. So now I'm going to use a little bit of algebra to determine what the oxidation state of manganese is. So I'm going to call it X. So the sum of the oxidation states of all of the atoms is equal to 0, since this doesn't have a charge. And then with a little bit of algebra, I get that X is equal to +7. So that means that the oxidation state of manganese is equal to +7. Next on to P4O10, this is a covalently bonded substance. Oxygen has a -2 oxidation state. Because this is covalently bonded, I cannot assume that phosphorus takes its typical -3. I'm going to need to use a little bit of algebra to determine this. And here it's going to be +3. Typically for oxidation states, we do label the plus sign. And now for H12O6, I don't know what carbon is just yet. I do know that hydrogen tends to take on +1. I do know that oxygen tends to take on -2. So then I'll use a little bit of algebra to figure out what carbon is. And I end up getting that X is equal to 0 here. So the oxidation state of carbon is 0. Pause here. We'll do one more example. So this is ionically bonded. So strontium is going to take on its common charge of +2. Chromium, this is a part of a polyatomic ion. I cannot make any assumptions about it just yet. Oxygen will take on a charge of -2, or an oxidation state of -2. Then I just do some algebra to get that chromium's oxidation state is +6. For NO3, I don't know anything about nitrogen. I do know that oxygen has a oxidation state of -2. I'll do some algebra. But here, instead of being equal to 0, it's going to be equal to the charge of the polyatomic ion, which in this case is -1. I do know that hydrogen is +1. I don't know anything about arsenic here just yet. I do know that oxygen is -2. And then I end up getting +7. And then last one, I don't have to do anything. This is an element on its own, so the oxidation state of nitrogen is just 0. That is all for today's video. Thank you so much for watching, and have a great night.